Hello, my name is Alexander Maximets and I'm a research engineer in Facebook AI Research working on Habitat and one of challenge organizers. My talk is divided in several parts. First, we will briefly talk about Habitat, then about proposed tasks for the challenge, concluding with winner announcement and submission analysis. Habitat platform was motivated by the emerging shift in the community from AI tasks based on internet image datasets to embodied AI tasks involving active agents, which perceive, plan to navigate, and interact with the world while communicating with people in natural language. Our high-level goal of this workshop is to take a step towards the Pascal ImageNet of embodied AI and create a simulation platform for consistent evaluation through community benchmarks, driven by transferability to reality. Our approach is to standardize embodied AI software stack. This starts with constructing a dataset layer that can use any existing and Fusion 3D environments. Then a simulator layer that learns from the successors of recent efforts and focuses on generality and performance. And on top of this, a task specification layer for defining and evaluating embodied AI tasks. These three layers form the Habitat platform. The Habitat simulation backend supports efficient and scalable rendering of navigation trajectories with a large number of 3D datasets at frame rate exceeding 10,000 frames per second, providing order of magnitude improvement compared to previous platforms, typically limited to hundreds frames per second. Habitat API framework allows flexible specification of embodied AI tasks, including point goal navigation, object semantic-based navigation, navigation to particular room, as well as tasks involving NLP reasoning, such as instructions following tasks and embodied question answering tasks. To motivate open competition, we organized a challenge and workshop on CVPR 2019, where we proposed to solve point goal navigation with GPS and compass on realistic scans of unseen houses. We had more than 10 teams participating and employing a variety of approaches, including classical ones, with really impressive results. The task was proposed was point goal navigation using GPS and compass and visual sensors without map. So agent has access to noiseless depth, noiseless RGB, and GPS and compass showing position of the goal with each step. We were privileged to award winners in person during Workshop CVPR 2019. Yeah, that was amazing times. This year, we proposed two different tasks for the community. PointNav task without localization sensors and object semantic navigation task. Let's dive in more details what is new compared to previous year's challenge for PointNav. As I mentioned earlier, we believe that embodied AI should be guided by transferability to reality. This year, we made a significant step to bring PointNav task closer to the running on the robot. So that means no GPS and compass. Goal specification is relative to episode start position and doesn't update during the navigation. Noisy actuations and sensing. As you can see, the same sequence of actions can lead to very different trajectories, how it's illustrated on this image. So while we still have 4 discrete actions, the action doesn't guarantee deterministic position orientation transformation. The actuation Locobot noise model was used for this. Visual sensors observations became noisy as well. Building a map leveraging depths became harder. Lastly, we disable unrealistic sliding along the walls that is default behavior for number of simulations. Surprisingly, that made training a real agent significantly harder. We used 98 high-quality scenes from Gibson dataset, same we used previous year. We want to thank Gibson team for providing this dataset and support. As we change agent specification to meet Lockerbot specification, we regenerated episodes dataset, and we call it PointNav version 2. Let's switch to semantic navigation task. The goal is specified by goal category and is static during episode. It tells the agent to which type of object it should navigate. We added GPS and compass relative to episode start position to model robot's odometry or other common localization sensors. There can be more than one object from the goal category. Navigation to any of them considered successful, but closest one is required for optimal performance. We used Matterport scenes dataset that contains 90 buildings with semantic annotation. As photorealistic scans of objects are used, each instance out of 8,000 goal objects is unique. We're thankful to Matterport for providing this dataset. Driven by experiments in reality, the agent specifications match Lockerbot specification for ObjectNav challenge, and we added two more actions, look up, look down, that can help with large object recognitions. We attempt to match the Azure Kinect camera specification for this challenge. Let's talk about ObjectNav evaluation. The goal object in this case on the image is a monitor, is highlighted in pink. We consider all points with 1 meter to the object surface, highlighted as a blue circle here, as potential success goal pods. From this area, we consider only navigable location for and that object can be seen with proper orientation of the camera, highlighted in green. These points cumulatively form the success zone. Locations where the agent calls stop, the episode would be considered successful. Blue arrows here show the shortest path from agent's random starting position and to the closest point in the success zone. We limited all shortest paths with 750 steps. As well as we check the ratio of geodesic distance to Euclidean distance to be at least 1.05 to exclude straightforward navigation. Here's an example of expert navigations toward the table. SPL is recommended by community to evaluate agents' navigation performance. Here you see that SPL has two components. First one is success binary component, and the second one is path efficiency toward the stop position. There are known issues with SPL metrics. First, SPL treats all failures as equal when they are not. There is high variance of the metric caused by binary success criteria. Then SPL has no penalty for turning, and as a result, results are not comparable for different datasets because of episode length is not incorporated in SPL. We considered alternative metrics called SoftSPL to measure navigation success. In SoftSPL, success is replaced with episode progress that can take any value from 0 to 1 depending on how close to the goal agent stopped. There are some issues with SPL that were fixed with SoftSPL. First, failures became comparable. And as a result of removing binary success criteria, variance decreased. I want to take a moment and talk about habitat evaluation challenge infrastructure improvements this year. Together with Eval.ai, we separated participants Docker from habitat evaluation Docker and made it independent one from another. That removed any possible impact of participants Docker on evaluation environment. Let's talk about habitat challenge statistics this year. We had 27 teams participated in the challenge. 6 teams submitted to challenge phase of PointNav task. 5 teams submitted to challenge phase of ObjectNav task. And we have 563 submissions to all phases in total. It's time to announce winners for PointNav challenge. And PointNav challenge first place is occupancy anticipation team with 0.21 SPL. Congratulations to the team. Occupancy anticipation team was led by Santosh Kumar and used occupancy anticipation for efficient exploration and navigation. So this approach was building map during navigation. And the PointNav challenge second place is ecolocalization team with 0.15 SPL. Congratulations. Ecolocalization team was led by Samyak Datta from Georgia Tech and used integrating egocentric localization for more realistic point goal navigation agents. This approach wasn't using any map, was not building a map during navigation. If we check SPL with confidence intervals, there is an interval overlap between second and third place. Here's a leaderboard sorted by SPL. As you see, occupancy anticipation team is first place, ego localization team is second place, and Dan team is third place, information bottleneck is fourth place, cog model team is fifth, and then Ukulab is sixth place. Here's PointNav challenge leaderboard sorted by SoftSPL. We encourage all participants fill details about their approaches and add links to detailed descriptions. We are curious what was your approaches. Let's dive into submission analysis. Analyzing minimal distance to the goal during episode navigation agents from all teams. On average, all teams were closer to the goal during episode than in terminal state. To show significance of stopping part of the task and estimate performance left on the table, we show SPL team could reach with perfect stop skills. For the for example, for ego localization team, this difference was pretty significant. To analyze impact of last mile, we show potential SPL chart with 2 times larger success zone. As we see, number of teams can double their performance if mastered at last mile navigation. If you take a look on collisions and episode lengths charts, surprising that top performing SPL entry has one of the longest episode and number of collisions. Let's switch to ObjectNav task and announce results of the challenge. And And ObjectNav challenge first place is Arnold team with 0.102 SPL. Congratulations to the team. Arnold team was led by Devendra Chaplot and used object goal navigation using goal-oriented semantic exploration. So this approach was building a map during the navigation. And ObjectNav challenge second place is SRBC Robert Sudar team with 0.099 SPL. Congratulations to the team. SRCB Robert Sudar team represents Samsung Research China and used memoryless vendor approach, which also is building a map during navigation. Winning teams will present their approaches in separate 5-minute talks. If we check SPL with confidence intervals here, there is a significant interval overlap between first and second place. Here's a leaderboard sorted by SPL. Place number 1 is Arnold team. Second place is SRCB Robot Sudar. Active Exploration team has third place. Fourth place is Black Sheep team. And fifth place is Blue Ox. Here's leaderboard sorted by SoftSPL. We encourage all participants to fill details about their approaches and add links to the detailed description. We compare success to SPL for participants. We can think about success as upper limit of SPL if all successful episodes would have optimal navigation. We see that agent path was at least twice longer compared to optimal one on average. If we check collisions and episode lengths for submissions, surprisingly, that agents that use more steps per episode had less collisions than top-performing entries with shorter episodes. All teams were closer to the goal at some point of navigation on average. There is a limited benefit for top-performing entries from perfect stopping skills. As a result, we assume improving navigation can bring more impact than mastering stopping. This is also supported by limited increase in performance if larger success zone would be used. Here we check average success per category. All object categories got their attention, and average success differs from 10% to 33% across all submissions. The tasks we proposed this year are considered multi-year effort, and as you can see, in comparison with previous year, this year tasks are far away from being solved. So this journey is 1% finished. As an announcement, we just released Habitat version 0.15 that includes all new tasks used for the challenges, rendering efficiency optimization using frustum calling, image data extraction API, which supports some requests like give me all views of couches from these scenes or something like that. Velocity control and configurable lighting setup. Organizing 2 separate tracks, improving system performance for new tasks, building and supporting testing infrastructure, generating data sets. That was a team effort. We want to thank our partners from other embodied AI challenges who work together to define the task specification and Eval AI for hosting our challenges. We think that's important that we converge on task specification and agent specification that are similar across challenges. We also want to thank our sponsors, Facebook AI Research and Google Cloud, for prizes. We are grateful everyone who had fun with us. We were very motivated by rain of submissions and competition we observed during last days of the challenge. We are going to keep test standard leaderboards active to be a source of truth for state-of-the-art performance for proposed tasks. So feel free to use these leaderboards to validate your ideas and the research projects. Thank you.